Welcome to PRISCI-ANTO Educational Academy, Chennai. Today, we are going to study the Lagrange's equation. The Lagrange's equation is PP plus QQ, which is equal to R. Capital P, small p, plus capital Q, small q, which is equal to R. This is Lagrange's equation. The auxiliary or subsidiary equation is dx divided by capital P, dy divided by capital Q, which is equal to dz divided by capital R. So the auxiliary equation for the Lagrange's equation is dx divided by capital P, which is equal to dy divided by capital Q, which is equal to dz divided by capital R. Let us solve one problem. Find the general solution of x into z square minus y square into p plus y into x square minus z square into q, which is equal to z into y square minus x square. First, you have to see the given problem, the type of the given problem. So here, what is the type of the given problem? PP plus QQ is equal to R. So x into z square minus y square into p. So capital P, small p. Capital P is x into z square minus y square. Capital Q is y into x square minus z square. Capital R is z into y square minus x square. So you have to compare with the Lagrange's equation type. Okay, so the given problem we can solve using the Lagrange's equation. So the given equation, first you have to write x into z square minus y square into p plus y into x square minus z square into q, which is equal to z into y square minus x square. So this equation is of the type PPQ plus QQ, which is equal to R. As I said you earlier, capital P is equal to x into z square minus y square. Capital Q is equal to y into x square minus z square. Capital R is equal to z into y square minus x square. So the auxiliary equations are dx divided by capital P, which is equal to dy divided by capital Q, which is equal to dz divided by capital R. So capital P, capital Q, capital R value is how to write. So dx divided by x into z square minus y square, which is equal to dy divided by y into x square minus z square, which is equal to dz divided by z into y square minus x square. Here you have to make the denominator to be 0 by multiplying any variable or any numbers. Okay, except 0. For example, first I am taking the multipliers. The multipliers are x comma y comma z. So because why I am taking these values x, y, z, because the denominator, that is the combination of x, y, z. That's why I'm taking x, y, z. So x, y, z, each term you have to multiply. For first term you have to multiply by x, second term you have to multiply by y, third term you have to multiply by z. So everything is equal here. For example, 1 by 2 is equal to 2 by 4 is equal to 3 by 6. 1 by 2 is equal to 2 by 4 is equal to 3 by 6. If you're adding the numerator as well as the denominator, the numerator will be 1 plus 2 plus 3. So 6. Okay, denominator is 2 plus 4 plus 6. 12. So 6 divided by 12, again it will become as 1 by 2. So 1 by 2 is equal to 2 by 4 is equal to 3 by 6, which is equal to numerator you have to add, denominator you have to add. So 1 plus 2 plus 3 divided by 2 plus 4 plus 6, which is equal to any one of this one, 1 by 2 or 2 by 4 or 3 by 6 you can write. You may write it. So therefore, x into dx divided by, if you multiply the denominator first term by x square into z square minus y square plus y dy divided by y square into x square minus z square plus z dz divided by z square into y square minus x square, which is equal to any one of this, because these three terms are equal. So you can write anything. So dz divided by z into y square minus x square. So denominators are becoming 0. So numerator is x dx plus y dy plus z dz divided by 0, which is equal to dz divided by z into y square minus x square. By cross multiplying, x dx plus y dy plus z dz is equal to 0. Integrating on both sides, you get x square by 2 plus y square by 2 plus z square by 2 is equal to c. If you're taking 2 is common in the denominator, so x square plus y square plus z square is equal to 2c. 2c is also again the constant. C is constant. 2c is also constant. So that's why I have taken here x square plus y square plus z square is equal to c1. General I have taken as c1. Next multipliers are I am choosing 1 by x, 1 by y, 1 by z, because already we have taken x comma y comma z. Now we have to take 1 by x comma 1 by y comma 1 by z. So each term you have to multiply 1 by x in the numerator as well as in the denominator also you have to multiply by 1 by x. So dx divided by x numerator is plus dy divided by y plus dz divided by z, whole divided by x into z square minus y square divided by x plus second term dy by y divided by y into x square minus z square divided by y plus dz by z, z into y square minus x square divided by z, which is equal to any one of the term you can write here. So the denominator will become a 0 because x divided by x will become 1. So z square minus y square plus x square minus z square plus y square minus x square in the denominators. So every denominator will become 0 if you're adding. So therefore, by cross multiplying, dx by x plus dy by y plus dz by z is equal to 0. So integrating on both sides, you will get dx by x if you're integrating log x, dy by y if you're integrating log y, dz by z if you're integrating log z. So log x plus log y plus log z is equal to log c, some constant. So log a plus log b plus log c is equal to log abc. So log x plus log y plus log z can be written as log xyz is equal to log c2. Log cancel. Xyz is equal to c2. The general solution is phi of or f of or g of anything you can write. So therefore, phi of c1 comma c2 is equal to 0. C1 already we have got. C2 is also just now we have got. So both you have to write here phi of x square plus y square plus z square comma xyz is equal to 0. Okay, one more problem. Let us see one more problem. Solve mz minus ny dou z by dou x plus nx minus lz dou z by dou y is equal to ly minus mx. So here from in the partial differential equation, from the notation we know very well, p is equal to dou z by dou x, q is equal to dou z by dou y. So therefore the given problem can be written as mz minus ny p plus nx minus lz q is equal to ly minus mx. So this equation looks like the type of Lagrange's pp plus qq is equal to capital R. So capital P is equal to mz minus ny. Capital Q is equal to nx minus lz. Capital R is equal to Ly minus mx. So the auxiliary equation is, or subsidiary equations are, dx divided by capital P, which is equal to dy divided by capital Q, which is equal to dz divided by capital R. So dx divided by mz minus ny, which is equal to dy divided by nx minus lz, which is equal to dz divided by ly minus mx. So now we have to choose the multipliers. How to choose the multipliers? In the subsidiary equation, in the denominator, that is the combination of xyz as well as lmn. xyz, lmn. So what is in the combination of xyz? What is missing in first term? Z is there, y is there, x is missing. So which one is missing? You may multiply it. So x, y, z, that is missing. In LMN combination, first term L is missing, second term M is missing, third term N is missing in LMN combination. Okay. So therefore the multipliers are x comma y comma z. So you have to multiply each term. First term multiply by x, second term multiply by y, numerator as well as denominator. Third term also multiply by z, numerator as well as denominator. So x dx divided by x into mz minus ny plus y dy divided by y into nx minus lz plus z dz divided by z into ly minus mx, which is equal to any one of the term you can write dx dz divided by ly minus mx. So if you're adding a numerator as well as a denominator will become 0. Numerator will be x dx plus y dy plus z dz is equal to 0 by cross multiplying. So x dx plus y dy plus z dz is equal to 0. Integrating on both sides, you will get x square by 2 plus y square by 2 plus z square by 2 is equal to c. So x square plus y square plus z square is equal to 2c. 2c can be taken as c1 because the 2c is also constant. In the previous example, I explained. Next multipliers are LMN. So multiply in the numerator L as well as the denominator multiply with L. So L dx divided by L into mz minus ny plus m dy divided by m into nx minus lz plus n dz divided by n into ly minus mx is equal to dz divided by ly minus mx. So numerator will become L dx plus m dy plus n dz whole divided by 0, which is equal to dz divided by ly minus mx. So integrating on both sides, by cross multiplying, it will become L dx plus m dy plus n dz is equal to 0. Integrating on both sides, you will get Lx plus my plus nz is equal to constant. So let us take the constant as C2. Therefore, the general solution is phi of C1 comma C2 is equal to 0. So phi of x square plus y square plus z square comma Lx plus my plus nz is equal to 0. Thank you all.